Okay, today we're going to look at a Xbar. This is an Xbar chart problem that we're going to take a look at. And those of you who know me from before, you know that I like to do a little cheat sheet. So as we read the problem, I'm going to start writing on the side. Pharmaceutical manufacturer requires that the average ingredient of a certain allergy pill to be 0.03 grams. That sounds an awful lot like mu. This is what it's supposed to be. Every pill is supposed to have the same thing. 0.03 grams is my mu, with a standard deviation of 0.02. So sigma is equal to 0.002, my apologies, grams. Okay. The FDA inspector inspects 10 batches. Here they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each batch of 100 pills. So right away, the first question you should already be thinking is, which one is N? Does N mean that I have 10 samples? Or does N mean that each one of these samples has 100 observations in each sample? Such that we have a total of 1,000 observations. And the answer is... The answer is 100. N is equal to the number of observations, right? Let's keep these guys in mind. They're going to come up after a while when we draw our chart. Matter of fact, there's probably enough space to draw our chart, right? Let me just scoot it over to the left. Let's go this way. All right, so let's do our Xbar chart, where mu is in the middle, and I have an upper control, I'm going to call it upper. My upper control limit, and it goes across the top. My mu is across the middle, and I have my lower control down here at the bottom. You're probably not going to be able to see that. So I'll put lower over here just so that you have it. All right, my mu is, you know what? I know what the answer is going to be. So let me do something that's going to make it easier for us later. Let me stretch this out further. And let me put the upper control limit here, upper control limit. And I'll put the lower control limit here. And then let's do some calculations. Okay, let me just make some space here. So in order to calculate upper control limit, we're going to do mu plus 3 sigma, where sigma is the sigma of the X bar, which is the same as saying mu plus 3 sigma over the square root of n. We're going to make a modification. And we're going to do the same thing with the minus, right? Mu minus for the lower control limit X bar, which is to say mu plus 3, minus 3 sigma over the square root of n. And now we've got our stuff over here. So this is plug and play. Let's plug and play. This is, that's not a good color. Let's go back to white. This is 0.03 plus 3 times 0.002 over the square root of 100, right? That's my n is 100, which is really going to be 10. That should be relatively easy. 0.03 minus, I did it again, minus 3.002 over the square root of 100. Let's keep calculating. Let's continue here. I'll do this in another color. 0.002 divided by 10. You know it's 10. Well, you know what? Maybe you don't know it's 10. 100 square root. 100 square root is 10. So that's not a problem. So we're going to take 0.002 divided by 10 is equal to 0.1. That's not right. 0.002 divided by 10 equals 0.0002. times 3 equals 0.0006. Okay, so this is going to be 3 plus, oh, I picked the wrong color. That's the fancy color. We don't need that right now. 3 plus 0.0006, which is 0.03. So this is, híjole, I'm just confusing you guys. 0.0306, and the other one is 0.03 minus 0.0006, which is 0.0294. This is my upper control limit, and this is my lower control limit. So that's great. Now we have that. Let's go back to our chart. My upper control limit is 0.0306. My mu is 0.0300 if you want to be precise. 0.0294 is my lower control limit, and we are good to go. So now I'm going to bring in, we don't really need this guy anymore. Now I'm going to look at my observations and I'm going to write them out. 0.032, this is where decimals are important here, right? This is not 0.0302. This is 0.032. 0.032 is way up here somewhere. 0.028, again, the decimals are important. Keep an eye on those decimals, is way down here somewhere. 0.031, again, way up there somewhere. 0.03, everything seems to be way out except for this guy. This is one is dead on the money, but everything else is way out of whack. Everything else seems to be way out of whack. And so that's a problem. If my upper control limit is here and my lower control limit is here, these pills are, 9 of the 10 pills are way out of performance. And this system is out of control. Out of control. With the exception of the one observation that's at 0.0300 exactly, all the other observations are out of control. And that's it.